Hi, and welcome to episode number 93 of the weekly Google Cloud Platform podcast. I am Francesc Campo, and I'm here with my colleague, Mark Mandel. Hey, Mark, how are you doing?
I am good. I'm in Seattle, so we're doing the remote thing today.
Yay, and I had all of the issues possible to have trying to set up the Mac today because I'm learning still. It's only 93 episodes, first time.
That's
anyway, we have today a very special episode. I'm actually very excited because we have one of the developer advocates from our team that we had not had before in the podcast.
Yeah, we have Melanie Warrick joining us today. She's going to talk to us about, what is AI? What does that mean? What does that relate to, machine learning? Is it just a brand new thing? Is it something just different? Who knows?
Yeah, I really liked it because this episode came up after basically having lunch. And we were talking about machine learning and AI and everything. And she was like, well, AI and machine learning are very different things. They were like, really? And she has opinions. She has opinions on this. So we decided to make an episode out of her opinions. And they're really interesting. So I'm very excited about the whole episode.
Yep. And then after that, we have our usual question of the week where we talk about, say you want to do something whenever any pod within your Kubernetes cluster is either created or destroyed. How do you do that?
Interesting. I have some ideas. But before we go to that and before we go with the main content, we have, as always, our cool things of the week. And we have 4 of them today. So I'm going to let you start.
Cool. So the first one here is around Stackdriver logging. It went GA a little while ago, but we've been basically talking to a bunch of the people who use this product, and we want to give them some new features that are super cool. So there's a bunch of stuff. We'll link to the full articles. Actually, there's a couple that come out of the blog post, but you can do neat stuff like being able to pull metrics out of logging now. So if you're tracking response times or any other types of metrics, you can pull that in. We've made it faster to make it log entries available within there. You can manage logs across organizations. So not only just managing logs within a project, you can do log aggregation exports across wide varieties of projects altogether. And you can also do this really cool thing, which I quite like, and we'll link to a longer article about it, which is now called exclusion filters, which is, say, for example, you might have debug statements that you have that are spitting out from your applications, but most of the time you actually don't care about them. So you can say, hey, I don't really care about these within Stackdriver, so that means it's not going to count towards the gigabytes or the storage costs that you would necessarily have there within your project. Which is probably good to know because Stackdriver logging now offers 50 gigabytes of logs per project per month for free. That'll be starting in December 1st. I think most people will probably not hit that 50 gigabytes, but some will. So be aware of that. That is coming. But yeah, so up to 50 gigabytes. But yeah, you can use exclusion filters, pull that down. Maybe if you're getting health checks, you're don't care about those. 200 requests, stuff like that. There's a longer conversation about that one of our other teammates, Aja Hamali, who wrote a whole article about preventing log waste with Stackdriver logging that we'll also link to as well.
Very cool. 50 gigabytes sounds like a lot, but I guess that some of our customers might be somewhere around there, even higher. So good to know. The second cool thing of the week is a new article. Is actually the third part of a trilogy on how to build conversational applications using cloud machine learning APIs. And it is really cool, partly because I'm actually preparing a talk for Sydney. I will be talking exactly about this topic. So it's very good to see that there's a new article on it. And basically it's about how do you describe intents for Google, not Google Home. The example is with Google Home, but you can actually do with whatever you want to do, actions on Google Home, but you can also do things like Facebook Messenger or Slack. And all of these things work through API.ai. And it is very cool because it is actually incredibly simple to use. You basically say, okay, if someone says, I'd like to buy some milk, then you know that you're going to relate that to a use case, which is to buy something, and the product is milk. And then you can make it be like, oh, well, we don't know the quantity, so let's ask the quantity. So you can actually create this kind of two-ways conversation that then you can use from any device. So you write it only once, you write your backend on the other side, and then people will be able to access your smart service from, as I was saying, Facebook Messenger or Slack, Google Home, but also Skype and Line and way more services. It's pretty cool.
That is cool. Well, I can't wait to see your talk, Francesc.
I can't wait to see it either. Especially, I can't wait to be done with it, especially the slides. But soon, I'll be working on that. If the organizer of the Cloud Summit Sydney is listening, my slides are done. Yes, they're totally finished.
So we've also got this book that has recently been released. I'm going to mess up all these names, but I'll try my best. So Tyler Akidel, Slava Cherniak, and Reuven Lax, their co-authors of an upcoming O'Reilly book called Streaming Systems, The What, Where, When, and How of Large-Scale Data Processing. Say that 3 times quickly. It's now in early release. Basically, it is intended to be the canonical resource for streaming big data and managing it and analyzing it and processing it at scale with like really big scale, right? Google scale, for people who want to be doing that as well in the companies that they are involved in. It looks like it's going to be a really cool book. We're going to have a link here basically to a little interview that was done with some of the authors there, telling about why they wrote the book, what sort of stuff people can look at, what do they really even mean by streaming, what does that mean, and sort of barriers to adoption, and really like, why did they write this thing in the first place?
So I'm going to ask you a question. What do you think is my favorite part of this book?
That it's all written in Java?
No. No. The fact that they're talking about streaming, and on the cover of the book, there's the fish, because, like a river.
Fishes, streams.
I'm easy humor. If you're really interested on it, you can access a thing with the free trial on O'Reilly, and also it's available on Amazon if you want to read it. Very cool book. And we're going to have our last cool thing of the week, which is something that, in my opinion, is super cool. I don't know if you've ever heard about this thing called Quick Draw. It's Quick Draw with Google.com. And it's this little app that you can use on your phone or on your computer. And basically, you access it and you draw whatever, and it guesses what it is, right? So it's like kind of like Pictionary. And this is powered by machine learning, of course, with neural networks and like convolutional neural networks. The cool thing is that convolutional networks are cool, but they need a lot of data. And we just open source that data, the data that was used to train that neural network, which is super useful, because then you can do whatever you want with that. You can train how to do a Pictionary again, but also you can do more analysis like, according to all of these drawings of a cat, what does a cat look like according to each country? And you can do an average and be like, oh, cats in Japan are actually slightly different to cats in the United States. It is really cool. You can do lots of really cool data processing. And also you can even understand the data even includes not only the finished drawing, but also how it was drawn. So you can actually follow the traces.
This is amazing. I'm just playing with the data explorer. And I clicked randomly. I clicked on parrot, and I'm currently looking at 163,567 parrot drawings made by real people on the internet.
Yeah, it is amazing.
You can even go through it. Yeah, you can go through it and be like, nope, that's not a parrot. This is so cool.
I know.
I just want to play with this all day.
I told you that's why that was a cool thing of the week. It is super cool. And if you're into machine learning, definitely check it out. But if you're not into machine learning, check it out, because it's actually lots of fun.
Yeah, now I'm going to stare at this for hours if I don't close it now. Cool. Well, I tell you what, why don't we go have a chat with our good friend Melanie and talk all about AI and ML and all that fun stuff.
Sure, let's do that. I am very, very happy today to welcome one of the latest additions to the Cloud Developer Advocacy team, Melanie Warrick. How are you doing, Melanie?
Doing great, thanks.
So I am very happy because we're going to be talking about a very interesting topic that we were actually discussing over lunch, and we decided that this conversation would be a great episode. So we're going to be talking about AI and stuffs. But before that, why don't you tell us a little bit about yourself? What did you do at Google? When did you join? Stuff like that.
Right. So I am a senior developer advocate at Google and started 4 months ago. I know you guys know about that. But prior to that, I was working for a startup on a neural net platform that was not TensorFlow and developing that out. And before that, I was working at Change.org, implementing machine learning algorithms into production. And Change.org, for anybody who doesn't know, is an online petition platform.
And somehow in one of those conferences, I think that you met Mark before that, right?
I did back in the day. Mark and I met at Strange Loop, actually.
A long time ago.
Yes.
In a land far away. But yes, I'm super. I got very excited when I found out Melanie was joining the team.
I know, we did.
Awesome. All right. Well, so we're here to talk about AI. So what is AI? Is it ML just with like a new coat of paint, or what's the deal?
That's what it feels like lately. Everything's called AI. So artificial intelligence in particular is, the actual definition is the science and engineering of technology or tech in some way, shape, or form. And this was initially coined back in the 50s to give us a history lesson, because I know that's what everybody wants to hear. But that's when it originally was labeled. And then over the years, it's been this process of seeing if we can actually achieve what people expect from it. But the reality is the expectations are constantly kind of changing. And what people really want when they say AI, a lot of people are really just looking for human-like artificial intelligence. They want it to see robots that are like humans. It's what we have fun with all of our sci-fi and fantasy. When we see it labeled today, most people are talking about what's known as narrow AI. And so they're expecting these technology that's really good in a specific area that's constantly learning and adapting. So that's where that term is getting used. And it's replacing a lot of times ML or machine learning. When machine learning, in essence, is the algorithms that are used in AI, or some of the algorithms that are used in AI. And when I say algorithms, I mean the math part, stuff that you use the computations for.
So you mentioned narrow intelligence. I can imagine, like, for instance, there was an example that we talked about as a cool thing of the week where there was like this farm of cucumbers, and there was something that was able to decide like the kind of cucumber that it was able to see. Like, that would be narrow, right?
Right. So what you're talking about in that cucumber example in particular, that is using an algorithm that is known as deep learning or neural nets. And in particular, that's a type of machine learning algorithm. And machine learning is a set of algorithms that are used in artificial intelligence. But it's not the only thing you use for artificial intelligence. And so for the cucumber example, and I'd have to look at it to really make sure I'm on point on this, but basically the cucumber example is machine learning for sure. And if it's continually adapting and changing in terms of how it operates, then technically it's narrow AI. Now, some would say, well, it's definitely AI based on this current paradigm we're living in. But, I would say for narrow AI, it's probably there, but it just depends on how much it continues to change and learn.
Cool. And you said something before that I thought was kind of interesting. You said that when people come to AI, what they often want is like a human-like response. But when you're talking about sort of narrow AI, I'm almost wondering whether the response you get out of machines is almost things that possibly humans couldn't do.
Right. So when I say when they come to AI and they want human-like response, they want to see a robot that really can think and feel and have ideas, and you have to say, when you look at like a car that can drive itself, right? Does it have an awareness of itself? Is it conscious? Can it generalize not just from driving to actually doing other things that are out there? And granted, it's pretty general to be able to drive, but in terms of narrow, you have to think about the fact that it's able to specifically be an expert in a specific field, and it could be better than humans in that field, like the AlphaGo. And DeepMind had successfully, beat a number of the best players in that field. That is a great example of where you have an algorithm that has been successfully trained to exceed what humans are capable of. So, that's definitely very possible.
So that would be narrow AI. And for general AI or wide AI, I don't know how to call it, other than like Prometheus and Alien and movies like that, like, is there something like that you can come up, like an actual use case of that kind of AI?
Do we have that now? As far as everybody knows, no. I mean, maybe somebody's hiding something in a back room somewhere, but as far as we all know, all we have right now is what's termed as narrow AI. We don't actually have general AI, which is what you usually mean when you're talking about anything that's human-like. And then there's super AI, because, you got to have like the super with all the various Superman, super shows that are coming out.
Now I'm excited.
I know. So this is where you start to get down to where they talk about singularity, and they say this is having AI that will go above and beyond what humans can actually understand. Like it's capable of doing things that go beyond our comprehension. And that's where you start to dive into like the real extreme, the world will come to an end or we will live forever, and there's some real serious concerns in this space for certain people. It gets used especially in the fun sci-fi fantasy world especially, but the realities of that, it's not really something that the people who are really researching the space are concerned about, and they don't see it as being a reality, if anytime soon.
Yeah, we'll come back to that, to those concerns a little bit later, but You mentioned something that I thought it was very interesting. You said that machine learning is the algorithms that are used for AI, but AI is more than machine learning.
Right.
What else do we have in AI that is not machine learning?
I mean, so machine learning is a field of research in the space, and there's a number of different fields. You have statistics and probability models that get intermixed with machine learning, but they are their own thing. They're not necessarily machine learning. You have graph theory. Some people might even touch on quantum mechanics, or quantum computing, which is also a little bit of more of a not fully concrete space itself, but it's fun to explore and think about what's the possibility there and how it could potentially have impact in AI at some point. So there are a number of different fields that will come together, sometimes on their own, sometimes in concert, to be able to achieve this artificial intelligence.
Cool. So probably bringing it back to, say, like Google Cloud or some of our open source projects, is TensorFlow AI or is it machine learning, or does it just depend on how you use the thing?
So TensorFlow primarily gets referenced and used in relation to deep learning. And as I mentioned, that's where you start talking about neural nets and applying neural nets, which are one of many algorithms that are in the machine learning space. So yes, it can play a role and be used and has been used in artificial intelligence projects. DeepMind, for example, currently, uses TensorFlow in some of their algorithms when they're doing anything around gaming. Not everything, but I know that it's used in some of the work that they're doing and other research spaces that they're in. Just because you're using TensorFlow doesn't mean you're doing AI.
Yeah, I mean, the hello world of TensorFlow is you do 2 + 2 and you run it says 4. That's probably not AI.
No. That's not.
Okay.
But yeah, it's definitely deep learning, or it can be deep learning, and primarily that is machine learning as the bigger umbrella.
Cool. So since you're a developer advocating, your main topic is AI, machine learning. Could you tell us a little bit about what kind of things can you do with AI or machine learning on Google Cloud Platform? Or what do people tend to do? What do you see the most often?
So in terms of machine learning on Google Cloud Platform is, it's basically servers. It's computers at the end of the day. So you can do whatever you want that you currently can do on Google Cloud Platform. That's something that I think is really important to stress, that, it's like any cloud platform you're going to use. You can use the tools, any tools you want. You just have to configure it.
So one of those tools may be for instance, TensorFlow, for which we have managed version, which is Cloud ML Engine.
What is it called now?
Yeah, that's my knowledge as well. So
cool. It's Cloud ML Engine, and but if you were interested in using something else other than TensorFlow, you could also use it.
Correct.
Now the thing is that I have no idea what other things are out there other than TensorFlow. So I don't know. Is there some other very well-known library, some competitor of TensorFlow that you've seen before and that people use it?
Right. So Keras gets referenced a lot because it's a great way to engage with TensorFlow or with other neural net platforms that exist out there. It's nice, sort of higher level abstract to engage with that space. So Keras is great. You can definitely use that on Google Cloud Platform. You just have to configure the actual servers to be able to use it. There are other libraries that are constantly being referenced, like PyTorch and Caffe, and there's definitely a few others that are out there that I would recommend exploring, because each one has its own value in terms of how it's being applied.
So I know with Cloud ML Engine, the TensorFlow setup can be the calculations can be distributed across multiple computers. If you were coming to GCP and you're using something else, like I think you call PyTorch or whatever it is, like something like that, do those come with tools that also will enable you to set up a multitude of computers so you can distribute that workload, or how does that kind of thing work?
Right. And I know we were talking about this earlier. So I wrote a blog post about this recently because I wanted to make sure it was clear to people that, TensorFlow is very valuable, and I recommend people exploring that. But if you are already using something and you want to be able to use Google Cloud Platform, I think it's important to understand that whatever you're using, you can bring over. So I wrote this post in particular to show you have to spend some time doing the configuration. Mm-hmm. If you already have an install script or some type of Docker image that you use to configure your instances, then you can use that. You don't have to spend the time doing the configuration. You just kick off whatever you need using Kubernetes, using whatever it is that will help get those servers up and running for you. You just have to have some way of doing the configuration, and then you can bring over your software.
So when you're seeing that software, as soon as Mark said like big scale and the cloud and stuff, I started thinking about big data. And I'm curious about the relationship between big data and things like Spark and MapReduce and stuff like that. And what we talk about machine learning and AI. Is AI part of big data? Is big data part of AI? What are the relationship there?
The relationship between big data and AI is that in some of these algorithms, and many of the algorithms, the data will actually help build them and make them successful and make them actually work well, especially when you get to neural nets. So big data is about having the data you need to train the model. And that's what it's all about. I mean, frankly, most of the work you do when you're building these models is getting the data and having the data cleaned and ready to go. And what is something I like to tell people all the time is never trust the data. The data needs to be fully vetted and cleaned and processed, and like 80% of your time can be spent on that. But you do have to spend the time figuring out what it is you have, what you need, and getting it into a format and into some type of data platform that will serve it to your models for training, for inference, for whatever it is you're going to do. Well, the tools we have for big data, we just have to be able to plug that into the software and the servers that you're using.
So now I'm also curious. I think you alluded earlier that sort of the whole aspect of AI is around sort of continual learning and like the platform learning from itself as it goes forward.
Right.
What does that look like? Are you just redoing the same training like over and over again, or is that like a slightly different process as it like grows? How does that work?
It can vary. When you're using some type of algorithm that, like a Markov algorithm, where the statistics that are involved in it will continually sort of adapt based on real-time readings of reactions from people. That would be one way where the algorithm itself is adapting as the reactions are coming in, and it's reading it real time. Sometimes you do have to do training offline, or many times you have to do training offline, where you will pick frequency of how often you do and with the new data that you've captured. So it can take a couple different forms in terms of like real time versus offline.
So following the same topic, since you have algorithms that continuously adapt to the conditions and to the context where they're executing, does that mean that you should be worried about the algorithms learning something wrong? By that I mean, like, how do you... Like, if, for instance, you have a self-driving car that learns how to learn by itself, right? Like, how to drive by itself. How do you make sure that it doesn't learn how to drive, like, backwards in the highway? The
human in the mix. You got to have some levels of humans evaluating the system, as well as you definitely need to put in safeguards. And yes, this is why I say never trust the data. You also don't fully trust the models. You have to constantly be testing and evaluating. We've seen examples of products that are out there that, didn't really work the way they expected. I think, frankly, as an engineer, you learn really quickly. You want to believe like you can write this code that you don't need to fully test, but all of it needs to be tested constantly, and you have to constantly be thinking about what it is you might be missing.
And how do you test it?
Well, depends on what you're doing. Sometimes you test it by writing tests. Sometimes you test it by exposing it to small samples. Sometimes you put it into the wild, and then you find out really quickly that maybe you shouldn't have, and you pull it back, and then you hope for better results the next time you do it.
Yeah, so I've definitely heard that in people's minds, people think, oh, I'm just going to write, like, I'm going to sprinkle like AI or ML over a thing, and it's just going to give me this perfect result. But it seems like it's more the AI or the ML might get you 80% of there, and then from there it's sort of nudging and scraping and crafting until you get a good product.
And what's something I like to stress to people, it's true with anything with modeling. When you're doing anything with machine learning, you have to come up with the right question or the right problem you're solving for. Before you pick any tools, before you do anything, then you start to have to think about, what is the data that I have to do this? And it doesn't have to be big data all the time. Like people can do, artificial intelligence with small samples. There's research on that, but you have to think about the data. What's the current setup of the data? And then you can start to do the model. And, it takes time to actually develop anything and to really see is it effective. And you have to also ask yourself, like, what is it you're trying to achieve for? We're typically evaluating and saying, accuracy is the easiest thing to explain. There's a number of ways to evaluate these metrics, but you have to ask yourself, like, at what percentage is acceptable? If it's something that's life or death, like I need to be 99.9999% accurate on this. If it's something that is like, we're playing a game and it needs to win most of the time, maybe 80 to 90% accuracy is acceptable.
This is where I ask questions based on very vague knowledge. I believe you can sort of overtrain if you have certain data sets that it works. Like, can you explain what that is and like how to like beat that, or like hopefully that doesn't happen? Is there a magic wand or something?
You guys are asking all the good questions. Like, tell us exactly. And it's interesting too, trying to do this verbally versus actually having. I usually love showing images because it sometimes helps kind of hit the point home. But yes, you can definitely overfit. That's and you can also underfit. So when you overfit, it means you've made it so that the model perfectly fits the training data set that it's been exposed to, but it doesn't generalize. It doesn't mean it can't. If you show it anything new that it hasn't seen before, then it won't be able to give any kind of prediction or classification that is actually useful because it's become so perfectly fit to the data. When you look at like drawing a line for linear regression to a data set, it's a great example. If you look up what overfitting looks like for just linear regression, I think you can get a good visual sense of what that looks like. And so people put what's known as regularization into your models. It makes it kind of fuzzy, makes it a little more general. And regularization is extremely key when you're doing deep learning and anything with neural nets, because that's an area that easily overfits. So you don't want it to be too perfectly matched to the training set, and you always want to set aside some data it's never seen before to see when you're testing it, does it work and apply.
Yeah, I heard an example that I thought was really cool. I think it was when we did the episode with Kaggle. On a very good example of overfitting was you try to predict the price of houses. Yeah. And one of the houses is like, let's say $2 million and has one broken door. And you could learn that whenever any house has a broken door, it should be $3 million, no matter how big it is. So it's like the specific thing is like, oh yeah, that's totally wrong. So yeah, I really like that. It's very interesting.
I don't know the exact details of this, but I had this example explained to me once where way back in the day when they were first exploring neural nets, they did this training on I think it was tanks, and they were trying to get a recognizing between the U.S. and Russian tanks. But the problem is they trained the actual algorithm with all these U.S. tanks that were taken by like really, well done marketing shots in really sunny spaces, whereas like the Russian tanks were all, like cloudy and difficult and grainy. When they tried it out in the real world, they had it thinking everything was a tank because it was grainy and like dark and and it had basically trained on the clouds and on like the sunshine versus the actual tank itself. So anyways, yes, it's funny when you start to dig into these algorithms to see what specifically is it really focusing on as the way to say this is my way to classify or predict. And it's very common that people resist using deep learning in particular because of that, because it's hard to fully break into. And they're working on this. It's called interpretability, but they're working on understanding like why is the algorithm picking the classification that it is.
That is actually super interesting, and I thought that was not a thing at all. Like once you have a neural network, if you have something that predicts numbers, somehow you can see like some layers inside of the neural network kind of showing like, well, this recognizes a circle, so you kind of figure out, is that a thing at higher scale? Like if you're trying to recognize, is this a cat? Yeah. Like, can you actually see that in the neural network?
Yeah, they've got some great examples out there in terms of showing what are these nets really seeing when it looks for the cat. What are some of the distinct, what's known as features to help identify the data set in particular. And there's great images out there actually online that will give you a perspective on how it focuses. Like classifying a 7 versus a 9, it'll look at that loop that the 9 will have that the 7 won't have. And that will be the feature that helps it distinguish between the two numbers and creates a higher probability.
So how does it do that, given like a neural net is essentially like it's math, right? So how can you determine that like from these numbers that there's a loop, like it's looking at the loop?
Well, yeah, now you want me to explain the math verbally. This is awesome. I mean, the way it's doing it, okay, there's it's basically converting the image. So in images in particular, it converts it all into numerical values. And then it, based on the way you do the math, it will find a way to emphasize specifically the numerical values for that part of the image. So the image itself gets converted into numerical values. There's a lot of math that's going on, and within that, it's emphasizing and saying, focus on this specific area. If you see this area in terms of numerical values, like, when I'm saying, let's say it's all grayscale, right? And ones and zeros, I'll just make it really simple, are focused in this specific area of the picture, then if you see that, then that's a high probability it's going to be a 9. So that's certain ways, and how you actually see that in the image itself, or how you see that in the neural net, is ways that we take the actual data set in the inside of the net and visualize it. I'm going to say that's my best way of explaining that, frankly, right now. But you find ways to sort of surface it and visualize and convert what the actual model looks like into some type of...
So I see that as almost like debugging a program, where you're actually able to see like the value of the variables when you're executing. You can kind of see it's like, oh, these are the pieces that are activating because C is around and whatever. Does that mean that whenever you've trained a big neural network that is able to recognize, let's say, circles, or like if it's able to recognize circles and lines and whatever, you could reuse that part to then train it on something else? Like, for instance, let's say, now you're going to try to recognize like diagrams or something like that.
So you're bringing up transfer learning, and that's become a really popular thing. A couple things I'll say about this around neural nets in particular. Neural nets came to popularity recently in the last few years because the computation power was there to actually do these computations you have to do, the intensive computation you have to do for it, and the data was available. What was initially popular for neural nets was feature engineering. Feature engineering meaning that you can run data through it, and you identify the primary important parts of the data that will help you build the model. And that's something that people had to do manually, and it was really intensive for a long time, but using a neural net made it a lot easier. Now, people are getting excited about what's known as transfer learning, where it more so with neural nets, because you've already got trained models that have been successful, and they're good at some type of image classification. And you can take parts of that model and apply it to a different image classification problem, and it's quick to train, quick to apply, quick to adapt. So it's cool. It's like figuring out a cat and a dog, and it gets used for like figuring out trees or something.
Yeah,
but
that's very human.
Yeah.
In that way, like if you've ever taken, like, I've done sport X and I used to do like one thing, and then I can do exactly the same thing. Like you took basketball skills, took it over to something like netball or something like that.
Yeah. That's
kind of super cool. So when is the robot uprising? And when should I expect the robot overlords?
Tomorrow.
Okay.
It's already here. You just didn't know that they were already telling you all the
I'm
things.
okay with this. I just thought I'd ask.
Yeah, no. I will say this. There was some research done around the superintelligence space, and all the people who were predicting when we were going to have superintelligence, and the averaged out the time frame, and the expectation is 2040.
Okay.
Yeah.
24. Oh, wow.
Oh, wow.
That's
sooner than I thought.
But you got time.
I got time.
You got plenty of time.
So there was this kind of clash of titans. There was Mark Zuckerberg and Elon Musk publicly discussing AI, and basically one saying it was like, AI is super dangerous, we should be super careful with it. The other one saying it was like, no, AI will save the world. What is your bend on this? Like, what is your opinion? Will AI destroy or save the world?
And it can only be one or the other. There's no in between.
Yeah.
I plead the fifth. I've seen this argument playing out, especially in the last couple of years. I think that the fear is used to get people to do things or to, react in ways that is not necessarily as beneficial, frankly. I think I'm not a fan of doing a lot of, let's be afraid, let's be really afraid. But I do think you need to be careful, and I know a lot of the researchers are trying to advocate for some of the challenges that they see coming, and trying to advocate responsibly for ways we can come up against those challenges. I know this isn't as much fun as like, yeah, they should throw down and fight it out, and this is the best person in there. I do see there's a lot of hype in this space. There's a lot of hype, and it's concerning in some ways, because I think people can get caught up in it and make poor decisions and buy into things that are not going to be useful for them in the long run. But unlike the past with AI, where we saw hype in the 50s and then this AI winter and hype again in like the 80s and 90s and again like a dropout, we are seeing real applications now, like identifying cancer cells in images that are beneficial, so beneficial to us. And so this isn't completely overhyped in terms of there's not some real value there. It's just you have to be careful about the hype and the fear and be realistic about like what is it being used for, where is it useful, and then, see what you need to do to be responsible about it.
You mentioned that researchers were being very careful about some concerns they had. Can you give an example of one of those concerns?
Some of the concerns I've heard more recently, and I think most people are talking about this, is jobs, right? Are we going to have automate away all the jobs? I don't know. I don't know. There's conversations around, do we automate them all away or do we just make new jobs, And so I'm not enough of an expert to be able to completely weigh in on, like, will this really happen? And I think most of the researchers don't fully know, but there's some conversations and discussion of, like, what does that look like? Some other concerns are along what you were talking about before with like testing, and how do we know we're putting stuff out into the wild that is not going to harm people, and make sure we have the right level. And I say harm, I'm not talking about them killing everybody off, but I am saying, having the right safeguards in place. And so, they're not completely off base, those who talk about this. And I know Yomux is one of those where they're trying to say, like, do we have the right safeguards to make sure that AI is going to be impactful in useful ways.
And like what you were talking about, making sure that a human stays in the mix. It's great if, you have a computer saying these are cancer cells or these are not, but having a doctor alongside saying, like, actually, let's double check that, and like we'll take an action, and I'll take that information as a suggestion or part of the packet of overall everything I'm doing. I think it's quite interesting. I've heard things of like chess leagues and stuff where they allow like human and computer AI interactions as teams being able to work together, and I think going forward, you could see that as being like the thing that happens. It's never just one or the other, it's both together.
Right.
We are running out of time, unfortunately. I'm having a great conversation. Before we finish up though, like, is there anything you want to make sure you plug, any events you're going to, maybe something you're super excited about that you just want to make sure that gets on the podcast before we finish up?
I'm looking forward to speaking on the AI panel at Grace Hopper in Orlando. So that's coming up in October. And I'll definitely want to mention that. But yeah, I've got a number of talks that are coming up, and I know like at Strata and O'Reilly's AI conference. So thanks for letting me plug.
We'll have all of those on the show notes. So in case anyone wants to go find you and ask you about Robotom Rising,
thanks.
Definitely have the things in that. Thank you so much.
Thank you.
This was amazing.
Thank you.
Thanks so much to Melanie for sharing her opinions on AI and machine learning and what are the differences, and also what's going to happen in the future if we're going to have to welcome our machine learned overlords.
Yeah, I welcome them. Totally. I just want to be clear on that.
Yeah, absolutely. Me too. I love them. Okay, so I guess it's time to go with our question of the week. Is about Kubernetes. So in Kubernetes, you have pods, and those pods, they die whenever they die. They're actually pretty short-lived sometimes. And whenever one dies, if you have a service that says, well, I should have, let's say, 10 instances of it, a new one is created, right? And you don't really have control on that. It just, whenever a pod dies, a new one is created. Now, how would you do something in between those actions? Meaning, like, if I want to do something at the moment a new pod is created, how do I do that? And if I want to do something at the moment a pod is killed or it's detected or considered to be dead, how do you do that?
Cool. So this is actually something that gets me kind of very excited about Kubernetes. So Kubernetes has a whole REST API as well as a series of clients for most languages like Go and Python and other ones as well. And what makes me get excited about Kubernetes is that Kubernetes is this amazing thing that does a lot of really like cool work in terms of like deployments and services and stuff like that. But it also gives you so much of the building blocks and the APIs to make it do all sorts of other interesting stuff programmatically, so you can really control it. So one of those things that it has is basically a whole like watch API. Most of the clients wrap that up. You can access it also directly through the REST API as well. You can basically say, hey, tell me like whenever this stuff happens. So for example, we're talking about here, hey, tell me whenever an event happens for a pod. And you can actually apply filters to those as well. And you can do fun stuff like that. And what's cool about that then is that I can just have like maybe a deployment that happens that sits on Kubernetes. It can connect to the Kubernetes API through the client, and it can be say, hey, tell me whenever something happens with a pod. And so when one gets created, it'll get a message saying something happened. When one gets deleted, it gets a message, something happened. And then programmatically, you could either tell Kubernetes to do something else, maybe fire off a message to a log, do some analytics or some sort of metrics. There's all sorts of fun stuff you could definitely do here.
So does that mean that you do a request and you give some kind of callback that like it will be called like a webhook, or is it like a long thing and you just get new messages from that connection?
So it depends on your client and how it does it. So I usually use the Go client. So what it normally does is it hands you back a channel, and then data gets pushed into that channel. If people aren't familiar with channels, think of it basically as like a blocking queue. And then data goes into that, and then I can just pick up that as it comes through. And
cool.
then I can do a go routine. So basically fork off another thread and keep on running from there. And it's really straightforward. And I don't have to worry about like starting processes or killing processes or tracking any of that stuff. Kubernetes handles all that for me, which is lovely.
Nice. My favorite thing is actually not only the fact that this API exists, but that this API is also used by kubectl, also known as kubectl, but kubectl in my house. And this is something that not that many people know, but you can do things like